Gravitational energy is the potential energy an object possesses due to its position in a gravitational field. Let's see gravitational energy in action through everyday examples. Motorcycle. When a motorcycle jumps from a hill, it possesses gravitational energy due to its elevated position. Bookshelf. A book resting at the top of a bookshelf has gravitational energy stored in it due to its position in Earth's gravitational field. Roller coaster. The wagon of a roller coaster at a peak position contains gravitational energy, which will be converted into kinetic energy as it descends. Crane. A weight hanging from a crane possesses gravitational energy based on its height above the ground. Wrecking ball. A stationary wrecking ball at its highest point holds gravitational energy that converts to kinetic energy when it descends. Pebble. When a pebble is lifted vertically by hand, it gains gravitational energy due to its increased height above the ground. Large rock. A large rock sitting precariously at the edge of a cliff contains gravitational energy based on its elevated position. Apple. An apple hanging from a branch showcasing gravitational energy as it remains supported above the ground due to its elevated position. Garden slide. A child sitting at the top of a garden slide possesses gravitational energy based on their elevated position. Waterfall. Water falling from the top of a waterfall possesses gravitational energy, which is converted into kinetic energy as it descends. So those were the examples of gravitational energy. Now let's look at the equation and solve a few related practice problems. Gravitational energy equation is commonly expressed as U is equal to mg delta h, where U represents gravitational energy, m is mass, g is gravitational acceleration, and delta h is the change in height. This equation helps calculate the gravitational potential energy of an object based on its mass, gravitational acceleration, and the change in height. Let's solve some practice problems to apply and understand the gravitational energy equation. Find the gravitational energy of a 15 kilograms crate lifted to a height of 3 meters above the ground. Assume a gravitational acceleration value of g equals 9.8 meters per second square. Note down the given information, input the values into the formula, and find the gravitational energy as requested. Find the gravitational energy, so U equals question mark. The mass is given as m is equal to 15 kilograms, and it is lifted to a height, delta h, is equal to 3 meters. The value of gravitational acceleration is given as g equals 9.8 meters per second square. Insert these values into the equation. U is equal to mg delta h. Therefore, the calculation becomes U equals 15 multiplied by 9.81 multiplied by 3, and we get the value of U as 441.45 joule. Therefore, the gravitational energy of the crate is 441.45 joule. Let's take one more practice problem. Determine the gravitational energy of an 8 kilograms object raised to a height of 8 meters above the ground. Use a gravitational acceleration value of g equals 9.8 meters per second square. Write down the provided data, apply the values to the formula, and find the gravitational energy as needed. We have to determine the gravitational energy, so U is equal to question mark. The mass is given as m equals 8 kilograms, and it is lifted to a height, delta h, equals 8 meters above the ground. Also, the gravitational acceleration g is given as 9.8 meters per second square. Place the given values into the equation. U is equal to mg delta h. So the value of U becomes 8 multiplied by 9.81 multiplied by 8, which gives the value of U as 627.84 joule. Hence, the gravitational energy of the object is 627.84 joule. So, that's gravitational energy. If you found this short breakdown helpful, show your support by liking, sharing, and hitting the subscribe button.